This video is going to focus on algebra, so simplifying and factorizing and those sorts of things. So take a problem like this. If you're supposed to simplify, in this case, it's all addition and subtraction, so you're going to combine like terms, adding and subtracting. So I've got my a's, and this is positive, and a positive 3a here gives me 3a plus, this is a 1a, right, is 4a. And then for my b's, I've got plus 1b minus 2b is going to be minus 1b or minus b. Combining like terms. No worries, we've seen that before. Now you may see a problem, you may have things like this, right? A squared times ab. Well, this is where you need to remember that any letter that doesn't have an exponent actually has an exponent of 1. So this is like a to the first and b to the first. And if we write this out longhand, it's a squared, which is a times a again, times b, right? And I have 3 a's, so this is a cubed b. Or if you remember the rule, when you are multiplying, and this is multiplication here, you add the exponents. So I've got a to the 2 plus 1, b to the 1, so I've got a cubed b, same answer. You have to be careful though, because there's a difference between this, a squared times a cubed times a squared, and a cubed squared, right? These are very different. This one means, in essence, a times a times a times a times a, right? A cubed times a squared. All of these are being multiplied. Whereas this one means take a cubed twice. So a cubed times a cubed times itself, so that's a times a times a, and a times a times a. And notice how we have very different number of a's here. So again, remembering that this is multiplication, we're going to add our exponents. So here I do a to the 3 plus 2 equals a to the 5th. But when it's multiplication, you add the exponents. But when we have an exponent on an exponent, like here on the right, here it's an exponent amplifying an exponent. Here you actually multiply the exponents. Okay? So here we're going to do a cubed times 2, and that's a to the 6th. And you'll notice that's a little messy 6. But that adds up, right, if we count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. A to the 5th, a to the 6th. Let's add on. The other thing you can have is the distributive property, right? So we could have 2 times x squared plus x. That's really simple, right? You're just going to distribute. Multiply the 2 out. 2x squared plus 2x. And then you make sure, double check, do you have any like terms or are you done? I have no like terms, so I'm done. But I could have x minus 3, x minus 1. And if I'm going to distribute here, remember you need to take this x and times against everything in the second parenthesis, so I get x squared minus 1x. And then I need to also multiply the negative 3 against everything in the second parenthesis, so I get negative 3x, and negative 3 times negative 1 is positive 3. And now I look for any like terms. Always want to simplify my answer. X squared has no like terms. Negative 1x minus 3x has like terms, so that's negative 4x, and plus 3. That's my answer. Now remember that there are two sort of special cases where, let's say we had x minus 4, x plus 4. And if we were to do the expansion of this fully, we would get x squared plus 4x minus 4x minus 16. And then combining like terms, these would be eliminated, and you'd end up with a difference of 2 squares. Remember, this is a difference of 2 squares because this is a square, and this is a square, and this is a difference as in negative sign, subtraction, difference of 2 squares, a square and a square. Okay? Now, by the same token, we can have x plus 4 the quantity squared, or that's the same thing as writing out x plus 4 times itself, like that. And again, if we expand that, x squared plus 4x again plus 16. All right. Combining like terms means these actually combine rather than cancel, and I end up with x squared plus 8x plus 16. This is a perfect square expansion. Okay? So, notice the difference. In here, we have a repeated of the exact same thing, right? The same thing twice. Here, we have a difference of signs, but otherwise, it's x and x, 4 and 4, but it's plus minus or negative plus, right? The signs are different. So when the signs are different, but everything else about them is the same, you have a difference of two squares, and you end up with the square of the x is x squared, the square of the 4 is 16, and it's a difference, so a subtraction of two squares. Whereas here, if you might remember the format of this is a squared plus 2ab plus b squared. In this case, a is the x, b is the 4, right? And x times 4 times 2 is going to be 8x. That's our, like that. So, look at the next slide. Those were factors, those were not factoring, those were expanding and simplifying. Now we're going to take it in the opposite direction, the exact same thing, and we're going to factor or factorize. So if I give you x squared minus 16, your goal is to get to x plus 4, x minus 4. Or if I give you x squared plus 8x plus 16, your goal is to get to x plus 4 times x plus 4, or x plus 4 squared. Okay? Now remember that even if you don't remember these special cases, you can solve all of these the same way with product sum factor PSF. The product is this last number, and your sum is, including the sign, the middle number. Okay? And then your factors are what you have to figure out. So my product in this case, let's talk about this one that we've marked, is positive 16, and my sum is positive 8. So what we do is we figure out what are the factors of 16. So I've got 16 and 1, 8 and 2, 4 and 4. Which of these add to 8? And that's this. And notice how then those get inputted. So you end up with two parentheses. We square root x squared. There's x and x. And because these are all positive, it's plus 4 and plus 4 using these two 4s. So let's do another and let's PSF this, okay? So, product sum factor. I've got product of negative 7, sum of positive 6, and I need factors of 7. Well, I only have 7 and 1, but I have to get negative 7. So negative 7 times positive 1, or 7 times negative 1 are my options. Which of these combinations, which one, adds to positive 6? That's what I have to ask. So this one adds to positive 6, right? So I do x plus 7 and x minus 1. How you check this, if you choose to check, is you take your x plus 7 and x minus 1, and you just go back and distribute it out. So x squared minus 1x, that's a 1, plus 7x minus 7. And then combine like terms, and that is right. So this video covered the content from chapters 9 and 13. Those are the problems you want to do from our cumulative review problems for practice, okay? And then bring questions to class after you check your answers so we can go over them.